you wanna introduce yourself as well?
Sure, yes. Yeah, my name is Rebecca Shaberdi, and I'm part of the marketing team, putting together all of these online virtual events. So we do have some more coming up this month. And we actually do have one on Friday that Samir is doing as well, which is actually the productivity tools to Civil 3D. So feel free to sign up for that. I believe it's for 11 a.m. Eastern time. It'll be about 30 minutes, right, Samir?
Yes, 30 minutes for the productivity tools, our MicroCAD tools to help you be more fast and efficient with Civil 3D.
Yes, perfect. So you can go to our website or send a message if you need the link, call or email us. And we do have 2 more coming up this month. And if there's anything you're interested in seeing, and a few other people as well, just let us know. We can find a way to get that for you. But yeah, I think we have almost everyone here, so can probably get started. And I'll go ahead and unmute everyone from this side if you guys have questions or anything like that. And you can also write them in the questions pane, and we'll answer that whenever we get a chance.
All right. Thank you, Rebecca. So today I'm gonna cover the fundamentals of Subassembly Composer. It's installed part of Civil 3D automatically. It's been around for a long time. It really takes your corridor modeling to the next level, using a lot more functionality that the corridor you can do versus sticking with the stock subassemblies. So I'll introduce the interface of the application. It is a separate application. I'll tell you how simple it is to use. Maybe a little bit intimidating, at least for me it was at the beginning, but it's actually pretty simple to work with. We're gonna dive a little deeper in it too. So using some parameters to control how the design is and letting the software kind of help us with the design decisions as we go along. And I'll just mention a couple of best practices you want to have in the back of your head when starting to use Subassembly Composer. The nice thing about it too is that Civil 3D actually installs with many different subassemblies that are available to you on your C drive. It's just not in Civil 3D. So if you just want to use it, you don't actually have to create it. There is a number of subassemblies that we have already installed for us. We just need to import them in Civil 3D. So feel free to ask any questions as we go along, like Rebecca mentioned, and I'll try to answer to the best of my abilities. A little bit of a reminder or a refresher on how subassemblies work in Civil 3D. So we have stock subassemblies. You're all familiar with the tool palette to create your assembly. Using these stock subassemblies that are available for us, there is basic ones, there is advanced ones, and the common thing here you want to notice is, first thing is that there is no spaces in the names. It's important that there is no space in the name. Secondly, when we dive a little deeper in the help file for any subassembly, we have certain information that is really useful for us to work with. First thing, I'm going to take a look at the basic lane transition subassembly here as just a refresher on how Civil 3D works. So with that particular one, the ones that are available in the tool palettes are generally coded in .NET as a programming language, versus Subassembly Composer is using Visual Basic. So just a side note. But in any case, they all share certain things. They share input parameters. Those are the parameters that we have available for us in the AutoCAD properties palette. Like we can change the width or slope or depth for anything. So first vocabulary we learn is the input parameters. Some subassemblies, those are a little bit advanced, contain target parameters as well. So those are a different type of parameter that we can use to drive the design, to change the input parameter on the fly based on some line work that we have in the drawing. So target parameters is something that we want to take care of in Subassembly Composer if we want to make use of that. And finally, one thing I want to pay close attention to is the point lengths and shape codes. So first thing that I realize here is everything has a code. So codes become really important. And we are going to be able to type the codes in that we want. So it's good practice to stick with as much as you can with the vocabulary that Autodesk uses, because that will let your code set styles work. Otherwise, if you start creating your own custom codes, which is sometimes necessary, you just need to realize that your code set style in your template will need to be adjusted so that it looks correctly in your drawing. But things are coded. There is points, there is links, and there is shapes. And that's how Subassembly Composer is basically working. We're going to be putting points next to points and connecting them with links. Once we have a closed shape, then we can give it a shape, and then we give it a code. When we give it a code, we can quantify it or apply a hatch style in Civil 3D. So that's just a quick little reminder. Now in Subassembly Composer, we have the same thing. This is the interface for Subassembly Composer, and on the left side, here is our points, links, and shapes, the basic fundamentals of any shape. We actually have a little bit more advanced geometry in here, like curves and fillets and arcs and things like that. Those are a little bit misleading because in reality, links are always straight lines. So we're going to take a look at what this curve one is. But the yellow ones here is what I'm going to show you today as a starting point. Section number 2 of the interface here is the flow chart, and this is how your points are going to connect to each other. So it's just a visual representation of how the flow is going to happen. And then section number 3 is the properties you give to each point. And those properties manage how they are created and located relative to the previous point. Finally, section number 4 is where those parameters are going to be created. So section number 4 makes your subassembly a bit more advanced using parameters that are available to you in the properties palette or target parameters that you can use to drive the corridor with your line work. So we're going to be creating some parameters. Parameters are not required, but they make your subassembly fairly limited and non-transferable from project to another. So we want to actually use it in a lot of cases. So with that said, my PowerPoint knowledge is to the max, and I'm going to flip to Civil 3D for a second and show you the demo data set that we're going to use today. Our data set that I prepared comes from Hawaii, and there is a highway here that crosses the mountains, and I thought like a nice demo to be making another tunnel that goes through the mountains. So we have 2 tunnels here. I'm going to design a 3rd tunnel, and we know that no stock sub-assemblies are available for us for tunnels, so I thought that would be a good practice to go through. So this is H3. It's an interstate in Hawaii. Fun fact, interstates in Hawaii do not cross any other state, which is funny, I think. But in any case, let's go ahead and start. So I designed the profile for the center line, and for practice, I designed an edge of pavement line here that will make use for targeting. So we can take a look at how we can use target parameters with Subassembly Composer. So with that said, your subassembly composer is available to you in the start menu. It's actually under the Autodesk folder, not the Autodesk Civil 3D folder. So Autodesk folder, you should see the subassembly composer link. Highly recommended that you use the same version of subassembly. So if you have Civil 3D 2020 and 2021, you want to use subassembly 21 if you intend on using that with Civil 3D 21. It does work, but sometimes there is a little glitches, so it's just a common practice to use the same version. When we open up Subassembly Composer, this is what we get, and you actually need all of these, but you can organize them. They look like palettes, and they are kind of palettes. You can organize your workspace as you feel like. If you screw it up too much, like I'm doing right now, because I was learning, you can always go to the View tab and restore the default layout, and that comes back to this layout. It happens to be a pretty convenient layout, and we'll just keep it that way it is, and we'll click on a point. We always start with a point and put the point in the flowchart. It's a drag and drop system. Once you have a point highlighted, there is the properties for that point show up at the bottom. All right, as well as you have a preview of the point. Now, in the preview, there is two preview modes. There is a roadway mode and a layout mode. The layout mode is what you see when you put the subassembly in your assembly, or when you are actually creating the assembly. The roadway mode is what happens when it's actually extruded through the corridor. So it can be wider, narrower, slopes are different, things like that. And that's what happens in the roadway mode. So I'm going to keep it on the roadway mode. Just realize that there is two previews that you can have access to here. Now, this point, the first point as a good practice always is at the origin. And the origin here is your insertion point when you are assembling your assembly. So one assembly sticks to the other, to the third and fourth and so on. There is usually one single grip, and that's your attachment point. This red cross here is the attachment point of the subassembly. It's not for the assembly, it's for the subassembly. So I'm gonna keep point number 1 here at the attachment point. It has a number. Notice it has a code. It's blank at the moment. And the method of placing that point, we have a number of methods. For now, I'm just gonna keep it delta X, delta Y. And basically it's gonna stick to the origin or attachment point, and it's not gonna move anywhere. So it's 0, 0. I'll drag another point. Drag another point, goes in here. You can use your arrow keys on the keyboard to kind of fine tune things. And when you put another point, it has a number, and then it doesn't know where to go. So I'm gonna give it a method for placement. And I'll say I want to make it change in the X direction and give it a slope perhaps. And you can see that it now placed itself relative to point number 1. And it placed itself at a particular slope and a particular width, or delta X. Now, this is great, but if we have a static number here for slope and delta X, that stuff is not going to show up in the AutoCAD properties palette. So it's very static. It's never going to be able to change. So it's very limiting in that way, because I can't create any lane that is wider than 10 feet now. So that's not useful. So what we want to do is go to the section number 4 here on the lower right. And we have a number of tabs. First tab is the packet settings. Packet settings is the name of the subassembly in Civil 3D. So common practice is that we keep this the same name as the file, but most importantly, it does not have spaces, because subassemblies do not have spaces in their names. So Make sure you don't have a space in there. And I'm gonna say I'm gonna be designing a lane for now. So I'm gonna do lane, and let's just say custom lane. Right, and description is optional for you. Help file, you can have an HTML help file if you like to associate with that, and an image. It's nice to have images. Usually at the end of when I finish, I create a screenshot of the preview here and save that with the image that will show up in Civil 3D later on as a quick reference, but again, not required. What's required is the subassembly name. Now we want to go to the input parameters here. And the input parameters by default already have a side. So you know that it always has a side. If you leave it at none, you can't use the subassembly mirror command. So it's really important to give it a default side. That way you can actually mirror it. If not, it's gonna work, but you can never use the mirror command. Most subassemblies in Civil 3D are already by default created on the right side, so we'll just keep it the same for consistency purposes. We'll just default to the right. Now to create another parameter, we simply hit create parameter and we give it a name. Parameters do not have spaces, so I'm going to say this is going to be width, and there is a number of types of parameters that we can use. So the width is going to be a number, so it's a double number. It is an input parameter, not an output parameter, and we can give it a default. All right, and the display name in your AutoCAD properties palette that can have a space. So if you want to make it nice and friendly, you can type lane width with a space, and that would look fine. Now, in order to use this parameter, we simply go to the properties of that point, and where delta x is, instead of having a static number here, we simply type the name of the parameter. All right, that means that if my default value here is 5, that updates the delta x. So whatever I put in my properties palette now is going to update my subassembly. So I can make this 15, and that would work. All right, let's do the same thing for slope. So I'll create this parameter for slope. All right, so I'll do default slope. And slope is going to be measured as, let's say, a grade. But that's a percent. So, and I'll say a grade of, let's say, by default is going to be 5%. And that I want to be able to go 5% positive or negative. I just want to type in a positive number here, but in my properties palette, I want to type in a positive number, but I want the subassembly to realize that that's going to be a negative slope. So I'm going to type in negative and then the name of the parameter, so slope. So I'll leave the negative sign in here, and that will adjust. So that would be my second parameter. Now, automatically it does connect the points, so we have this idea of links, right? So that's the normal terminology. A link connects 2 points. We can turn that on and off. All right, and that's now we have a link. Now we can keep dragging these things in. However, to make the flowchart nice and tidy, we can make use of some advanced functionality here. So I'm going to drag in. You have another flowchart or a sequence, and those would be like a nested block in AutoCAD when you have a block inside a block, but you can reuse the block over and over. So I'm going to drag in a sequence here because I might want to reuse the next portion over and over in other cases. So this is not mandatory, but it's nice way to keep your flowchart tidy. I'll drag in a sequence, and in my sequence, I'll double click the sequence. Now we have the breadcrumbs here, subassembly, and then in the flowchart, and then the sequence. And in the sequence, I'm gonna start creating the pavement itself. I'll drag another point. It's a very tedious process. You just keep dragging points. I'll drag another point. That next point is gonna be, let's say, goes down a little bit. So I'm gonna say 0.3 is gonna be delta x, delta y, measured from 0.1 because I want to keep it parametric. Wherever 0.1 goes, 0.3 goes. And that way I'm gonna, for depth, I'm gonna say I want it to be 0.5. That's gonna be the thickness of pavement. That actually goes up. So I'm gonna do negative 0.5 and that goes down. Drag another point and we'll do, this one is gonna be from 0.2 and that again is gonna be negative 0.5. Again, I can actually create a parameter for depth that I can control the depth or thickness of pavement from the AutoCAD properties palette. And then finally, I'll drag in a link. All right, a link doesn't know what to connect to, so I'll say I want to connect P3 to P4. So I'll say start point P3, end point P4, and I get a line. So I have, I need a couple of more lines here, P1 to P3. I'll drag another link, P1 to P3. Now I created a line right here. And we'll do the same thing for the end, P2 to P4, drag another link, P2 to P4. Now we have 4 points connected with lines or links. And then that's all nice and everything, but if I actually want to hatch the pavement or get compute the material, then I actually have to have a shape. So I'll drag a shape, all right? So that way I can apply stuff using the code set style. I can use to apply something to that shape. And the shape needs a bounded or closed area. So you simply use the little, you can type the links in, but this is really handy. Click that guy and you highlight inside the closed area and now you have a shape. So now we have a shape and that's all nice. So we can definitely use this in Civil 3D, right? Like it is right now. A lot of things are not going to show up though in Civil 3D because remember, we have point numbers and link numbers, but no codes yet. So very important is coding things. So I'll go back to my first flowchart and start coding things. When I start coding things, I'd like to turn on in my preview here the code so I make sure that I didn't miss anything. Turn on the code. And then right below the numbers, I start coding things. And it's good practice to use the names that are available from Civil 3D. That way the code set styles that you have created in your template still continue to work. But it's not mandatory because you really can type anything. All right. The thing though to remember is that if you want to type something as text, it has to be in quotes. Otherwise, it'll be a parameter, just like how we typed in width and slope here without quotes. That was a parameter. So a code is just simply text. So that needs to be in quotes. So my point code here for point number 1 would be, let's say, crown, because Autodesk uses that terminology pretty often. Some codes, some points are double coded. Right? So sometimes we want to create a surface from all the top links really quickly. So that way I can actually double code my points. So I do a comma and then another quote and then I type in top. That way, whenever I want to create a surface from the top codes, that will be captured. All right, so this is now double coded. Let's do the same thing for point number 2. Point 2 is going to be, let's say, ETW as well as top. All right. What about the link? The link also needs to be coded. So for L1 here, we have L1. We'll code that. I'm just gonna code it as pave as well as top. All right. Not mandatory to double code things, but it's often helpful when we start creating surfaces really quickly. And because I have the codes on, it shows up in the preview nicely. All right, we can continue doing the rest of the points, but it's the same idea. It's just really important to code these things because that's how your feature lines are going to be generated, your surfaces are going to be generated, and so on. So, but I just don't want to spend a lot of time on that one. Now, let's say this is all nice, but let's say I actually want to be able to drive the width of the lane using target parameters. All right, right now, the lane is only going to be whatever I input in my properties palette. So if I want to target something, then I gotta go to my target parameters tab and create a target parameter. So I'll go ahead and create a parameter, and I'll give it a name. I'm going to say this is going to be lane offset, no spaces. All right. There is 3 different types of targeting that we're aware of. There is an elevation target, an offset target, which is a horizontal target, and a surface target. Usually, often you need it for grading to surface. I do realize that in Civil 3D, we can actually also target pipe networks in a handful of subassemblies. We do not have that availability in Subassembly Composer yet. When we create a target, we get this little, in roadway mode, we get a toggle in our preview. All right, so that we click it, we can move it around. Depending on what kind of type of target you have, you'll get a different arrow direction, but they all move the same way. You can click it and move it around in your preview. So I'm gonna keep it at 20 just for show here. And now I want to make sure that my point number 2, not only does it follow my input parameter, but I also want it in some cases to follow my target parameter. So I'll go back to point number 2 in my flowchart. And we've placed this point based on slope and delta x. And we also have availability here for offset target. And I have none right now. Because I have created one offset target, it shows up in my drop-down menu. Now I can select it. So now I have an override. You can do the same thing with elevation targets. So now wherever that target is, my lane follows. And because the rest of the shape of pavement is parametric to point number 2, it also follows. So that's all nice. Let's test it out now. So once we are happy with our design, most importantly, we have a subassembly name in the packet settings. I'm going to give it a save. I'll just save it to my desktop. And I like to save my packet files the same as the subassembly name. The PKT file is a zip file. If you actually rename it to .zip, you can extract it and see what's contained in it. But Civil 3D will only realize the PKT extension. All right, back in Civil 3D, now we have it, we saved it, it's all nice. We will open up our, there is 2 methods of bringing that subassembly in. One method is using the Insert tab. We'll have Import Subassemblies button, or my preferred method is right from the tool palettes. I often create the custom palette for myself. I'm going to name it custom just to keep my custom stuff organized. And then I right click on the palette and say Import Subassemblies. And this way I'm going to be able to browse to my subassembly. Hit open it. I'm going to put it in my custom palette, hit OK, and that shows up. Now, when we just did that, it actually copied the subassembly into my specified program files C drive folder. So it's really important that you centralize these packet files in some network directory so all of your team have access to them. Because if another member is opening the drawing and does not have access to the location of the subassembly, the corridor is not going to be able to be modified. It's not going to be able to work with because the subassembly is not available. The subassembly is saved externally to the drawing, and it needs to travel with the drawing if you share the drawing to other people. So I'm going to use the custom lane subassembly, and I have a typical section here. Put it on the right side, and I put it on the left side. If I take a look at it, we have a couple of input parameters that we did, lane width and lane slope, and here's my default. And I'm happy with that for now. I'm just gonna create a quick corridor for it. I'm not gonna do the whole run just because it's a long alignment that I have here. So I'm just gonna do a little section out of it so that we don't wait for the software to process too long. Any questions so far? All right. So I'm gonna create the corridor right from in this section, and we now have a quick little corridor using our custom, very simple subassembly. And if we take a look at it in Object Viewer, just make sure that there is actually a corridor in here. I don't know why I'm on X-ray. Yeah, so I didn't code my shape, so that's why nothing shows up. The shape doesn't have any, but the lines, the feature lines showed up for edge of pavement because that was coded ETW. All right, now let's say I want to drive this corridor with the edge of pavement line that I have here, the green line, right, to overwrite the input parameters. We can do that just because we created the target parameter. So I'm gonna take a look at my corridor. And for targeting, we have the lane offset, and I'm gonna do on the left side, choose my alignment. And now the corridor follows the edge of pavement line. So this is a really easy way of designing, because now we have our lines and the corridor is just following our line work. So now we've created a number of parameters. All right, let's take this one step further and start looking at what makes this awesome. So with Civil 3D and Subassembly Composer, you want to let the software decide for you some things. And oftentimes the classic example is cut and fill. We want to do something in cut versus we want to do something different in fill. But what if we want to do different things in cut? Like if the existing grade is like about 2% slope, 2 to 1 slope, I want to do something, but 3 to 1, I want to do something else. Well, we can make the software decide for us by having a decision node. So decision, we drag in a decision and we type in the Visual Basic code here that will decide for us something. Actually, before that, I want to do some more things. So I'll just create a surface target so that I'm going to calculate things based on the surface. So where is my existing grade? So now I have another target parameter. And I'm going to make use of this auxiliary point. An auxiliary point does not actually show up in Civil 3D. It's just something that we can use in Subassembly Composer to make some calculations for us. So an auxiliary point is just like a normal point. It just never shows up in Civil 3D. And this auxiliary point, I'm going to put it on the surface. So wherever the surface is, it's just going to sit on the surface. So I'm going to say delta x on surface, and the surface target is my EG. So here is AP1, auxiliary point number 1, and wherever my existing grade is, the surface shows up. And I want to make a decision on that. I want to ask a question. So I'm going to drag in a decision, and I'm going to say, is the point above the profile or below the profile? Basically, if it's above the profile, it will create a tunnel for me. If it's below, then it will just grade to the surface. So I need to ask the question. And we enter a Visual Basic code here. The Visual Basic code is very simple to put in, and I'm going to tell you where to find the documentation for it. So in the simple subassembly help, when you open subassembly help, there is a section here for entering or calculating property data, and then you click on API functions, and I'm only going to look at the P point class. A little bit of programming, but not much. And in here, it tells you how to put this expressions in. So I want to say based on the point name, and then the X value or the Y value. So you have X and Y value, the offset value, the elevation value, and so on. So there is so many different function names here that you can reference. But basically, based on that, I'm going to say whatever AP1 is, I'm going to say AP1 dot, and I'm interested in the Y value, so dot Y. So that's basically the surface elevation. Is that bigger or smaller? So I'm going to do the, is that bigger? And then where P1 is. So P1 is following my design profile. So P1 dot Y, right? Just like that. So that means is AP1, the elevation of AP1, is that bigger than the elevation of my crown? If bigger, it's going to do something. If smaller, it's going to do something else. So if it's bigger, then I have a tunnel condition. So I'm going to type in tunnel. If it's smaller, I actually don't need a tunnel. So no tunnel. All right. So now we have a decision, and we have an equation here that will do some math for us. And we have two sides, tunnel or no tunnel. If there is a tunnel, I want to drag another point. And you can kind of put this right here. And P5 is going to be located right on top of P5. So P5 here, I'm going to put it on top of P1. And the delta Y is going to be, let's say the height of the tunnel is like 25 feet. And we can also make that as a parameter. So it shows up top here. Now I want to create a curve, so I'll drag in a curve. And the curve is not really a curve, it's a tessellated line. So I'm going to use a parabola, and I'm going to specify the tessellation. This is very similar to your mid-ordinate distance when you create a surface. So the higher the number, the better accuracy you get around that curve. So I'll just keep it at 10. And then I'll do my start point is going to be, let's say, 0.2. End point is P5. That doesn't seem like it does anything. Oh, mid-ordinate right there, 0.1. So that's not good. I think I need to go the opposite direction. Ah, there we go. Let's do like 2. That's not a nice curve. Let's do 5. So that I'm happy with that shape. So, and that will, it will divide the length of that curve into 10 pieces of links, because I have arc tessellation is 10. So that's what's going to happen in a tunnel condition where my existing grade EG here is going to be above my crown. But if it's at the bottom, then it goes away. And that's because I'm in roadway mode here as a preview. So when it goes away, I need to tell it, hey, grade to the surface. So I'll do another point. And you can take this arrow off and then hover over the end here and kind of drag it in. So no tunnel condition. And when we have no tunnel condition, I'm going to locate P point number 6 here, slope to surface. And I'll say I want to slope it at -2. That's fine. We can create an input parameter for that. but then I'm gonna just put it to the surface, and that will get calculated from point number 2. So let's do like a 2-to-1 slope. There's a pretty steep slope.
Samir, we also have a question as well, asking, can the size of the pick box be adjusted?
No, there isn't a lot of customization to the user interface, unfortunately. The only thing that you can change is just where those windows are, but nothing else. You can't change any other colors or anything else like that. It is small, yeah. Where is my P6? P6 is slope to surface, and not sure why P6 is not showing up for me. Uh, all right, I'm not sure why it's not showing up for me, but I was gonna show a little point right here. So let me open one that I've prepared and show you a little bit. So this one I have coded, and I have my target surface here. When I put my EG at the bottom here, I now have a point number 6, and it goes down. So P6 here goes from P2, and I've coded it daylight, top, and datum with an input parameter of daylight slope for the slope of the daylighting. So there is a little glitch here, but I'm not sure what. Don't want to spend too much time figuring out where P6 is not showing up. But those are the arrows here are your target parameters, and then everything is coded. As long as everything is coded, then you can make use of it in Civil 3D. And we have a decision now. When we have a certain condition, we do something. We have a certain other condition, we do something else. And this is the power of Subassembly Composer right here, the decision making. So I'm gonna close this and go back to Civil 3D, and I'm just gonna show you the final product. Import Subassembly. I'll import my finished Subassembly. And this one, I made a little screenshot with a picture for it. And I'm gonna replace this guy and this guy. All right, so even though I said keep targets, it's probably not gonna keep the targets. So let's double check. Yep, never does keep the targets for some reason. All right, so let's take a look. Now that I've created this, if I go Object Viewer, you can see forgot one target. All right, so now it's grading to the surface where it doesn't find a necessity for a tunnel, and then it creates a tunnel if the grade is way above the profile. So let's, if we take a look at it in 3D view, here we have a tunnel condition based on that subassembly, and then I didn't create any regions or anything. That's just because of the decision that I put in here. It figured out where it needs to put a tunnel and where it needs to actually grade to the surface, as well as it's following the edge of pavement line. So that was all done by the decision making. All right, so let's see what we have for questions. All right. Anyone have any questions so far? All right, so I thought I'd make this a little bit fun, and this is besides the point with subassembly composer, but we have tunnels here. We need light, so I thought it would be cool to put in some light fixtures, and I'm gonna do that with Dynamo. So Dynamo is a separate application, and I've created a small little graph that will actually put in light fixtures for us. So I want to show you that just for fun as you think of your questions. I have a question for you. Speaking of corridors, hopefully someone knows what is the longest interstate in the United States. So I'm curious. So I'm gonna run this Dynamo player here, and this graph will basically put in light fixture blocks for me along the corridor. So simple as that. Now we can take a look at it and see. My computer is going a little slow. And corridor. Just like it. All right, Rebecca, do you want to say anything? As I try to figure out why it's not clicking.
No, just if there's any other questions people have about this, or any questions about any of the upcoming webinars we have, or just, maybe even general civil questions. Hopefully you guys have the questions pane or like the little pop out. You can throw that question in there, and we can, answer that privately to you if there's a specific, issue or question that you have. Or if you need any further assistance with anything else civil, you can let us know. I think that's all I have. Are you doing okay over there, Samir?
Yeah, I got it to work finally. So I put the lights in, and then the subassembly is changing the tunnels to a graded section. Finally worked for me. I was having clicking issues. But I hope that was helpful for everyone. If you have any questions or thoughts that you want to share, feel free to call or email us. And the answer to the longest highway in the United States is actually I-90, so the Mass Pike. That goes from Boston to Seattle. So thank you for your time again, and I hope that was helpful to everyone.
Thank you, everyone.